We're going to look at examples of conversion problems. We're starting off with wanting to convert 3 quarts to tablespoons. So it's really helpful to have handy a list of conversions, and there's one posted on Foxtail that you can access. So we're starting off with quarts, and we're given a quantity of quarts. So we're going to start off with what we know, what we're giving. Now, at the end of the day, we want tablespoons. So I'm going to say equals, and I'll leave a space, and tablespoons. And now we had to fill in this in-between spot with conversions to get quarts to tablespoons. So we're going to multiply 3 quarts by a ratio of quarts in the denominator and then some other quantity in the numerator. So if you use that conversion sheet, you see that we can't go directly from quarts to tablespoons, but we can go from quarts to cups. So for every 1 quart, that is equivalent to 4 cups, and I'll use a C for a cup. So this ratio, 4 cups to 1 quart, is another way of representing 1. Right? It's the same quantity. 4 cups is the same quantity as 1 quart. So you have the same thing over itself, top and bottom in a numerator. That always equals 1. Okay, now that's great. That's going to give us cups, but we want tablespoons. So again, we're going to multiply by another ratio. And we always know we want to cancel out all of the units, all of the labels that aren't the tablespoons, right? We want to end up with tablespoons. So to get that cups to cancel out, we got to put that cups in the denominator. Now looking at that conversion sheet, all right, we do have cups to tablespoons. We have that in 1/2 of a cup. There are 8 tablespoons. Okay, so again, we have identical quantities, numerator and denominator, so that is just like multiplying by 1. Okay, that is then going to give us tablespoons. All right, so if we go through and just cancel, if we just go ahead and cancel just the labels, right? Remember this 3 quarts, this is like over 1. So we have a quarts in the numerator and denominator, those cancel out. And then we have a cups in numerator and denominator. And then we are left with tablespoons. That is the only label that we're left with. All right, so now we just need to do the multiplication. So we got 3 times 4 times 8, and then dividing that by 1/2, or dividing that by 0.5, or multiplying by 2, we end up with 192 tablespoons. Okay, convert 70 ounces to kilograms. So again, we start off with what's given us. So we will have 70 ounces, and we want to end up with kilograms. So I'm just going to put that over here just to remind us where we're going. Okay, because we're going to be using the conversion sheet to come up with the different ratios to get from ounces to kilograms. All right, we can't go directly from ounces to kilograms, but we can go from ounces to grams. All right, so if we look at that conversion sheet, we see that for every 1 ounce, that is equivalent to 28.35 grams. All right, so we've got the same quantity top and bottom, so that's just a 1. And then our next ratio, we can go from grams to kilograms. And just to remind us how we know where to put which of those things, all right, we want this grams to cancel out. So we want to put grams in the denominator, so those will cancel out, and then kilograms in the numerator. There are 1,000 grams in a kilogram. Okay, and if we now just cancel out our units, all right, ounce, ounce, gram, gram, and that is going to leave us with just kilograms, which is what we wanted. And so now we do the multiplication. 70 times 28.35 divided by 7, and we get 1.9845 kilograms. Okay, here's another conversion problem, this time in a word problem. If a prescription for this drug, azithromycin, calls for 40 milligrams per dose and the solution on hand has a concentration of 200 milligrams of the drug azithromycin per 5 milliliters, how much of the solution should be given to the patient per dose? Okay, so we want to identify two things: what we start with and then where we're headed. And probably the easiest thing to write down, the easiest thing to identify to know where we're headed is what units is that thing going to be in. Now, it doesn't actually say specifically, but how much of the solution? Well, solution you want to think of as some kind of liquid, and liquid is going to be measured in milliliters. Okay, so this is asking how many milliliters. So what we're looking for at the end here is milliliters. Okay, all right, now we want to, well, what do we start with? Okay, well, the prescription calls for 40 milligrams, or I'm sorry, 400 milligrams. So that's what we got to make sure we have in that solution is the 400 milligrams. So that's our starting place. And so we need to do the conversion from milligrams to milliliters. So we're going to multiply this by a ratio that has the equivalent quantity in the numerator and denominator. And it's given to us, the concentration is 200 milligrams per 5 milliliters. So it's given to us, and it looks like 200 is in the numerator, 5 is in the denominator, but we have to remember we want that milligrams to cancel out. So we want milligrams to be in the denominator and the milliliter to be in the numerator. So that means we're going to have 5 milliliters over 200 milligrams. Okay, so now we can cancel the units, which we just have milligrams to cancel. So that's going to give us milliliters because that's all we have left. And doing that multiplication and division, 400 times 5 divided by 200, that gives us 10 milliliters. Okay, this is also a word problem for conversion. A prescription for amoxicillin calls for 500 milligrams per dose, and the solution on hand has a concentration of 125 milligrams per 5 milliliters. How much of the solution should be given to the patient per dose? So, sorry, you can ignore this page number. And again, we have that how much of the solution. So what we're looking for is a liquid measure of milliliters. All right, we are told that we've got to have 500 milligrams in the dose, so that's what we start off with. And then we're going to multiply that by the ratio that's given, making sure we put milligrams in the denominator. And then milliliters goes in the numerator, so we get 5 over 125. And doing that multiplication, well, first we can cancel out our milligrams, and then doing the multiplication, 500 times 5 divided by 125, we get 20 milliliters.